Okay, next part. Let's ask a different question. Instead of limits going to infinity, we now want to look at limits at infinity. So let's do a quick review. When we have rational functions, we have horizontal asymptotes. The way we find those is by comparing the first terms, or I should say the greatest degree terms. So I look at the numerator, find the term with the highest exponent, ignore the rest. Look at the denominator, find the term with the highest exponent, and ignore the rest. Then I simplify the division of the two highest terms. So that would be 1/2. So that means this one would have a horizontal asymptote of 1/2. Let's do this next one. Look at the numerator, take the highest, get rid of the others. Denominator, take the highest, get rid of the others. So this would be 5x to the 4th over 10x to the 5th. Simplify that, I would get 1 over 2x. Now, horizontal asymptotes are thinking about what does this graph look when I'm talking about really big numbers. So if I look at 1 over 2x, if x is like 5 million, 1 over 2 times 5 million, what is that fraction getting really, really close to? 0. So this horizontal asymptote is actually going to get closer and closer to 0. Now here's this general rule. Anytime the degree on bottom is greater than degree on top, then it goes to 0. So that's a little general rule for you there. Okay, let's try this one. Cross out the lower ones. 5x to the 4th over 10x cubed gives me 1/2 x. So this one does not have a horizontal asymptote. 1/2 x is linear, so it actually has a linear or a slant asymptote, but that's not what we're asking about. We're only asking about horizontal asymptotes. So this, we would say, no horizontal asymptote. So, in general, if the degrees are the same, it simplifies, has an asymptote. If the degree on bottom is bigger, then our asymptote is 0. If the degree on top is bigger, there is no horizontal asymptote. In the next video, we're going to apply those 3 rules to limits.